Hello everyone, I'm Nikhil Dilkar, Senior Product Line Manager for Monza at Impinj, and on behalf of all of us at Impinj, Xerafy, and MPI, I would like to welcome you all to today's webinar. Joining me today is Evelyn Ong from Xerafy and Patrick Stalling from MPI Labels. We'll be talking about the revolutionary metal skin inlay. We're expecting to spend about 30 minutes on the presentation and questions and answers. I'll start off by describing the opportunity and the key challenges for on-metal RFID applications, and then we'll look at how Impinj Monza 4 Cutie chips in the metal skin inlay help address those challenges. Evelyn from Xerafy will cover details and case studies about their metal skin inlay, and then finally Patrick from MPI Labels will talk about label conversion and the availability of the product. Now, before we begin today's call, I would like to remind you that we will be addressing all questions at the end of the presentation. If you look at the right side of your screen, you will see a question and answer box. If at any time you have a question during the presentation, please enter it in the box and we'll address it at the end of the call. Now, we do have a lot of people joining us today, so if for any reason we are unable to answer your question during the call, we'll follow up with you offline. All right, let's get ahead and let's get started. For those of you who don't know Impinj, let me start off by describing the company and our products. Impinj is a leading provider of UHF RFID products. We have three product families: Monza, Indy, and Speedway. Impinj Monza tag chips are the highest selling UHF RFID tag chips on the market. Our Indy reader chips power most of the UHF RFID reader devices on the market, and our Speedway readers are the most widely deployed UHF fixed readers today. As a result, we have a very unique position and perspective in this industry. We see technical and business trends from both the reader and the tag side, and this enables us to bring exciting innovations to market that create new opportunities for our end users as well as our channel partners. Today, we'll discuss how our innovation and our partnership with Xerafy has resulted in a revolutionary product for metal asset tracking. The interest in on-metal RFID applications has been booming for the last few years. These applications include tracking of IT assets such as laptops and servers in data centers, maintaining inventory of tools, and tracking returnable transit items such as shipping containers and cylinders. There is also strong interest in inventory tracking and theft deterrence of high-value metallic goods such as pipes and cables. VDC estimates the passive EPC Gen 2 ruggedized read-on-metal tag market at about $80 million this year. And this market is expected to grow with a compounded annual growth rate of 48%. Now, while these numbers are great for tag manufacturers, they also point to large opportunities for our Speedway partners and RFID systems integrators. And yet, while the business case for using RFID for on-metal applications has been clear for some time now, there have been technical challenges with these applications, making them difficult to deploy. Analysis of the feedback from our partners and customers points us to these 6 major challenges. There are several tags in the market today that are optimized for great performance when applied to metal, but the performance degrades dramatically when the tag is taken off metal. This does not work for the end user who wants to standardize on a single tag, but is disappointed to see the performance degradation when the tag is, say, applied to a plastic tool versus maybe a metal tool. Most on-metal tags available today are hard tags. Most of them are thick, and this poses challenges when applying to curved surfaces such as cylinders and pipes. In several of these applications, the tagged items are thrown around or installed randomly, and as a result, the orientation of the tag becomes an issue. While some tags perform great in one position, as soon as they are rotated by 90 degrees, or in some cases 180 degrees, their performance drops to unacceptable levels. There's also the issue of the hidden cost of applying human-readable labels to these hard tags. This one frustrates many end users. Unlike a regular inlay which can be converted into a label and printed upon, the process of sticking labels with barcodes or text on top of hard tags is still a very manual process involving human labor. This becomes very cumbersome, especially if it's managed in the field. And to add to all of this, there is also the most basic challenges of making the tag physically rugged and operational over all the different global frequencies. Now, over the last few years, we have seen significant progress by tag manufacturers to address one or more of these challenges, but more and more applications and end users are requiring all of these challenges be addressed. And that's why here at Impinj, we are excited about the metal skin inlay from Xerafy and how its innovative design addresses these challenges. At the heart of the metal skin tag is the Impinj Monza 4QT tag chip. Monza 4QT has 512 bits of user memory, which can be used to store key information about the tag product. Its ability to permanently lock sections of the user memory so that certain information can never be erased or overwritten, combined with the Cutie privacy feature, which can be used to switch between public and private profiles, makes this a very versatile tag chip. However, what makes Monza 4QT stand out for on-metal applications is its unique patent-pending architecture that provides two fully independent antenna ports. This Impinj innovation results in high read performance in true omnidirectional tags. These Monza 4QT chips add up the power gained from the two independent antennas, and this results in a boost in the read range. Also, using a symmetric antenna design, Monza 4QT chips can eliminate blind spots, making the read range independent of the tag orientation. And you can see this effect in the plot of the read range in this picture on the right. The blue line in this plot is a conventional dipole antenna design, and you can see here how the read range drops significantly when read at the 90 and the 270 degree angles. The red line is a plot of the read range of a fully symmetric true 3D antenna, taking advantage of the dual independent ports of the Monza 4QT. In this case, you can see that the read range is much more consistent over all the angles. The metal skin takes advantage of these advanced capabilities of Monza 4QT to gain high read range, orientation and sensitivity, and broadband operation to cover the global frequencies. In addition, using a very clever design, it delivers some groundbreaking capabilities. So let's hear about it directly from Xerafy. To talk more about the metal skin inlay, I would now like to introduce Evelyn Ong, Director of Sales at Xerafy. Evelyn?
Thank you, Nikhil. I would like to first introduce Xerafy. Xerafy is a manufacturer of UHF RFID on-metal tags. We are a customer-centric, innovation-driven company striving to offer creative and practical solutions to our customers. We pride ourselves with having the world's smallest and most extreme EPC UHF RFID on-metal tags. We are also very successful in providing tag solutions in major industrial sectors such as automotive, aerospace, energy, IT, construction, and healthcare. We have also won various widely recognized industry awards such as Red Herring and Frost & Sullivan. Headquartered in Hong Kong, we have offices in Dallas, UK, and Shanghai. With some background information about traditional on-metal tags provided by Nikhil, we are excited to introduce Xerafy's latest product, the Metal Skin. The Metal Skin series is a family of products which is the world's first inlay-based product that works on metal. It is essentially a high-performance and cost-effective inlay. It performs reliably on and off metal, making it suitable for customers requiring to tag a mixture of metallic and non-metallic assets. The Metal Skin is deliberately designed to conform and work seamlessly with standard label converting processes, therefore eliminating the need for customized tooling and processes. It is also lightweight and flexible with paper-thin profile that is workable with standard RFID printers readily available in the market. Based on Impinj Monza 4 Cutie chip, Metal Skin will be supplied in roll form. The picture on the top right-hand corner shows two different kinds of Metal Skin inlays, namely mercury and titanium. The mercury can be read up to 4 meters on metal, 5 meters off metal with a fixed reader, and is already available in mass production. The second one, titanium, is a lot smaller. It is designed for small item-level tagging, such as iPhones and perfume bottles. Titanium will be launched in the second half of the year. Due to the unique features of the Metal Skin, a whole array of new applications is now possible. Some examples are product authentication for high-value, high-volume foil-based products, such as cigarette cartons and perfume boxes. Metal Skin is also suitable for curved surface assets, such as cylinders, pipes, cables, drums, and cakes. Due to the thin profile of the Metal Skin, it is also suitable for IT asset tracking, as well as mobile assets such as iPad, laptops, and scanners. In fact, as long as the asset is metallic and does not need to survive through harsh environment, the Metal Skin will be suitable. The next two slides illustrate two different case studies of the use of Metal Skin. In both cases, traditional on-metal hard tags are unsuitable for their applications and therefore require the Metal Skin. The first case study is an IT asset tracking application. We are currently working with a large manufacturer in the U.S. to track mobile devices such as iPad and laptops that are used by employees. Tracking of such assets are necessary to increase a sense of accountability and reduce theft. This customer requires a tag that works on metal surfaces, small and thin enough that would fit with the iPad case after attachment. Traditional on-metal tags are unsuitable due to the thickness and bulkiness. The solution that incorporates the Metal Skin was proposed and accepted by the customer. The Metal Skin is first converted into a label and then printed with barcode and human-readable information. At check-in and check-out, the mobile device ID is associated with the employee ID, which is linked to the company's security system and inventory management system. The benefits enjoyed by this customer are increased sense of accountability, resulting in reduction of thefts, fast and effective inventory management, as well as reduction in replacement costs of lost assets. The next case study is also an asset tracking application, but of a slightly different nature. This customer is in the alcohol distribution business and requires a solution to track metal beer kegs. As these beer kegs move in the supply chain from the facility to the distributor that delivers it to a bar, restaurant, or liquor store, and then return to the brewery for servicing and refilling, they can sometimes get misplaced and accounted for. They are also unable to ascertain the source of damage when a damaged beer keg is returned. Traditional thick on-metal tags were used during the initial pilot, but were found to be unsuitable as the tags get knocked off upon impact during handling. As these tags are rigid and inflexible, they also have difficulty finding a suitable location on the keg to tag. The customer is thrilled with the Metal Skin solution and immediately deployed them to the existing inventory of beer kegs. Together with fixed and mobile reader infrastructure installation, the customer is able to enjoy a wide range of benefits, such as improved customer service and delivery, processing and pickup, decrease in the number of man-hours spent tracking the kegs, reduction in cost of replacement, as well as the ability to accurately track damaged tapes to source. In summary, the benefits of metal skin over other auto ID methods in the read-on-metal space can be broadly categorized into 3 points. Most importantly, due to its construction and design, metal skin costs approximately only a quarter of the standard on-metal hard tags in the market. We believe cost is always a consideration for customers, especially in large volume projects. Besides the cost of tag, the fact that the metal skin is a standard label product also means that the entire cost of deployment will reduce as it is easily attached on metal. Secondly, the metal skin is deliberately designed to work with existing standard processes, be it converting, encoding, or printing. This is important to our customers as they do not need to invest in new equipment, tooling, or printers to handle metal skin. Thirdly, the use of Impinj Monza 4 Cutie IC enables us to design a tag with global frequency. This is necessary for customers who need to track assets across different frequency regimes. It is also designed to have similar performance regardless of reading on or off metal. The flexibility of it allows tagging of a whole range of curved surface and small foil-based assets. Xerafy works with a wide range of partners to bring to customer a complete solution. In the case of the metal skin series, we'll be working very closely with the converter channels. Converters have the expertise and experience to offer a different variety of metal skin-based products according to customers' requirements. To ensure customers are properly serviced, Xerafy has developed a converter qualification program that identifies and qualifies competent and reliable converters. Products made by converters will be tested to ensure a certain level of quality standard is achieved. Contact information of these qualified converters will be published at Xerafy's website on an ongoing basis. The next couple of slides will be presented by one of our qualified converters, NPI labels, which will be represented by the RFID project manager, Patrick Stalling.
Thanks, Eve. MPI was established in 1968 and is one of the largest privately held label companies in the U.S. with 10 different locations. We have 10 years in the RFID and label printing industry to go with our 44 years of printing experience. MPI offers flexo and digital printing along with shrink sleeves, labeling systems, RFID readers and tags, service bureau and contact labeling, just to touch on a few of our many capabilities. Next slide. We offer the metal skin tag with several different face stock options to include white or clear films, direct thermal or thermal transfer, along with fluorescence or just a simple semi-gloss paper. We can also deliver these tags with a variety of adhesives such as high temperature, removable, permanent, ultra removable, freezer, to name a few of our many options. We can deliver the metal skin tags with either a blank or pre-printed face up to 10 colors, or we can offer digital print if you require. Next slide. MPI can supply 8-inch OD rolls with 6-inch ID cores, or we can deliver the metal skin tags to you in a sheeted version. We can supply the tags encoded with variable data printed with a durable ribbon. Our lead time is currently 5 to 8 weeks, and our pricing is normally under $1. However, like everything else today, pricing is dependent upon quantity and custom materials. Thank you.
Thanks, Patrick. Now, before we get started, I'd like to remind you that if you have a question, please type it into the question box. In the event that we are unable to answer your question during the call, we will be sure to follow up with you offline. So I'll start reading out some of these questions. So the first question we have here is, will we get a copy of this webinar? So the Impinj team has recorded the webinar, and we'll be posting it to our website within the next couple of weeks. Next question is, this is a question for you, Evelyn. How do I get a sample of the metal skin tag?
Right now, you can see my email address. Drop me an email with your shipping information, and we will be able to send you samples within the next couple of days.
Okay, very good. Another question for you, Evelyn. What is the total thickness of the metal skin for tracking iPads?
The thickness of the dry inlay currently is 0.66 millimeters. After conversion with a layer of paper face stock as well as a layer of adhesive, usually the standard thickness is about 0.8. It will be less than 1 millimeter in total thickness.
Okay. So another question we have here is, the question says, two contrary statements were made. Number one, metal skin works on both metal and non-metal assets. And number two, as long as asset is metallic, metal skin will work. Which one is correct? So the answer to that one is the metal skin inlay actually has good performance on both metal as well as non-metal assets. The way it's designed, it's got a very thin metal film inside, so it takes advantage of that metal film that's inside instead of taking advantage of the metal asset that it's tagged on. And that's how you get the performance both on and off metal. The next question is for you, Evelyn. How many current qualified converters do you have?
Currently, we have about 3 in US and 2 in Europe. It is still an ongoing process, so you do not see their names in the website yet, but we are working very closely with these 5 converters.
Okay. The next question is about the read range. Again, this question for you, Evelyn. What is the read range with a portable reader?
The read range of a portable reader approximately is about half of what we get on a fixed reader. There are also variants of portable readers depending on the power that they emit. So typically, if it's going to read 4 meters with a fixed reader, it should read about 2 to 2.5 meters with a fixed reader, with a mobile reader.
Okay. Another question about the design of the metal skin tag for you, Evelyn. Is the metal skin tag on a high permeability substrate?
I don't quite get that question. I guess the answer is no. It is made of standard PET material.
Okay. All right, so we have another one here. This one is for Patrick. Are your labels available for Zebra printers?
Yes, they are.
Okay, very good. The next question is about the temperature spec. Maybe you can answer this, Evelyn. Is this a high temperature metal tag? Can it survive 120 degrees Celsius?
The operating temperature that we put in our data sheet is 85 degrees Celsius. That is the highest temperature for the dry inlay. We have converter partners who are able to encapsulate it with a different kind of material to make it even higher temperature resistant. So it's possible to achieve 100 degrees Celsius if that is required, but that would require some form of customization and encapsulation.
Okay, thank you. Next question again is about the tag for you, Evelyn. Is this tag qualified for different kinds of metals?
The tag, we designed the metal skin with with generic metal in mind. And when I say that, and generic metal means a different kind of metal with similar dielectric values. So the family of metals have similar dielectric values. So the answer is yes, it works on different kind of metals. To bring the question to the next level, we do also have applications with different kind of composite, like carbon fiber. Those will work as well, although they are of a different dielectric, mainly because the metal skin is designed for on and off metal. So yes, it covers different kind of metal.
Okay. Next question is about the chip attach. Does Xerafy do the chip attach themselves, or is it contracted out to somebody else?
Xerafy have a list of manufacturers whom we work with to do the chip attachment.
Okay. So I'll go through a couple more questions. I think that's all the time that we have left now. Are these tags RoHS compliant?
The tags are not yet RoHS certified. Because it's a very new product, so we have not gone through that process, but we believe that it wouldn't have any issue getting it certified.
Okay, and then the last one I have here that I think we have just enough time for is, can you affix this tag to compound radius surfaces?
Yes, you are able to attach to assets with a radius. There is a guideline in our metal skin guideline that says there's a minimum curve radius that the metal skin will perform. So if you drop me an email, I can send you that document. Basically, it describes, it provides some dimensions of the curve diameter not to exceed before the performance drops.
All right, very good. So that is all the time we have for questions today. If we didn't answer your question during the call, we will follow up with you offline. Again, we truly appreciate your taking the time to join us today. Thank you.